And welcome to lesson 1.2.2 in Algebra 2. This is our final video for Unit 1. I hope that you have gotten a lot out of these videos. If there's something that you feel like you need more information on and another video would be helpful, please let me know in person or via email, and I'd be happy to add some more to it. But this is the last of the new material for this unit. So that brings us to our essential question. How can you solve an absolute value equation? Last time we looked at graphing absolute value functions. This time we're going to look at when we have an equation, what it is we need to do to solve it. So there's a couple different ways anytime you're solving an equation. The first way we're going to look at is how to solve by graphing. And in order to solve by graphing, there's a couple of things you have to do. The first thing you have to do is you have to graph both sides of your equation, and then you have to find the points of intersection. And those points of intersection will be your solutions. I'm going to show this to you with a Desmos graph, but let me just show you the equations that we'll be doing. So the first one is 2 times the absolute value of x minus 5 minus 4 equals 2. The next one we'll look at is the absolute value of x plus 4 plus 3 equals 5. And the last one is 1/2 absolute value of x plus 1 equals negative 3. So those are the three equations we'll look at. And now I'm going to bring the graph over so I can show you how we're going to find those solutions. So I'm using Desmos just to make my life a little bit easier. You could also do this graphing by hand, using what you know about transformations of functions. So when you're doing these in Desmos, you have to graph each side of the equation separately. So my first equation, one side is y equals 2 times the absolute value of x minus 5, and then minus 4 on the outside. So you can see in this, to do absolute value, you use the abbreviation ABS. And then the other side of our equation was y equals 2. So pretty quickly when I plug that in, you can see the nice thing about Desmos is that the intersection points come up right away. So the 2 points of intersection for this are 2, 2, and 8, 2. I'm going to write those down in my notes. You can also write them in your notes. But what we're looking at is just where this line crosses our absolute value function. While we're here, I just want to show you something. If instead of y equals 2, this was 1, you can see we'd still have two solutions for this. And if we keep changing that a little bit, if I go to negative 3, so now I'd be looking at an equation that had a negative 3 on the right instead of a 2. So we're getting to where our solutions are closer together. At negative 4, we have exactly one solution because we're right at that vertex of the absolute value function. And if I change this to negative 5, suddenly I have no solutions. And that's because the absolute value function in this case is opening up. Negative 5 is underneath that. And what that means is there's no number I could plug in here for x and get a solution to this equation. We'll look at that with algebra in a few minutes too. So on to the second example. That's also in your notes, I hope. And that was y equals the absolute value of x plus 4 and plus 3 at the end. Whoops, plus 3. And our second equation would be y equals 5. Again, I'm just using the two equations. So here we can see our two solutions are at negative 6, 5, and negative 2, 5. Notice the y values are 5. That makes sense because that's one side of our equation, and our x values are negative 6 and negative 2. So our two solutions are negative 6 and negative 2. If we plug those both in here, negative 6 plus 4, negative 6 plus 4 is negative 2. Absolute value that is positive 2. Positive 2 plus 3 gives us the 5 we're looking for. And our last example, y equals 1/2 absolute value x plus 1 And the second equation is y equals -3. And here's an example where we have no solution. Our absolute value function is up here, our line is down here. They never meet, so we know we have no solution. If you were doing this by hand, you would look at this equation and you'd think about what the vertex is. Think about this being a shift 1 to the left, no shift up or down, which is why our vertex here goes at -1, 0. And then from that -1, 0, that slope of 1/2 means to get to the next point, we go up 1 and over 2, which puts us right there. And then up 1 and over 2 again, which puts us right, I can't quite get it, 3 and 2, there it is, right there, and so on. So you can graph these by hand, and then y equals -3 is just a horizontal line down at -3. So graphing them by hand is also an option when you're trying to find the solutions. So this last one had no solution because those lines never intersect. So in addition to solving by graphing, we can also solve algebraically. So solving by graphing was one way, and solving algebraically is the second. Solving algebraically is kind of what it sounds like. You solve using algebra. And what we're going to do then is we're going to use the same inverse operations to isolate our variable. So when we're solving, we start with subtraction or addition, then we undo any multiplication or division, then we undo any exponents or roots, and finally we undo parentheses. And when you're working with absolute value functions, the absolute value function fits in here. With parentheses. And I'll show you that in a couple of different examples. And remember, if we're solving an absolute value function algebraically, we will usually end up with 2 answers. NSWERS, or we could have 1 or 0 in some cases. But most of the time, we're going to have 2 answers. So don't be scared by that. That's what always messes people up first. So let's look at a couple of examples of what the algebra actually looks like. So, notes, questions. Remember, write down your questions over here if they come to your mind while I'm doing notes over here. That's what this is for, okay? So use that question space. Example numero uno of solving algebraically. 2 times the absolute value of x minus 5 minus 4 equals 2. And just so you know, this is the same one we did before. I just want to show you how it works with algebra so you can see where these are all coming from. Okay, so we look at this equation, we draw in our nice little line, we think about undoing subtraction or addition first, and remember that these absolute value symbols are like parentheses. So we're going to wait and we're going to undo those later. So first we're going to add 4 on both sides. And when we add 4 on both sides, we're going to get 2 times the absolute value of x minus 5. -4 plus 4 is 0, so I put nothing there, and 2 plus 4 is 6. Now I undo any multiplication or division. Remember, this really means 2 times the absolute value of that. So I'm going to divide both sides by 2. And when I divide by 2 on the left, those cancel. That's the whole point of dividing. On the right, I get 6 divided by 2, which equals 3. So I get absolute value of x minus 5 equals 3. At this point, we have to stop for a minute, and we have to think about what the absolute value means. So if we know the absolute value of x minus 5 equals 3, remember the absolute value means that we took the positive answer. So that's why this has to be a positive 3. But if we think about this, there's really 2 possibilities, and that's where our 2 answers come in. If the absolute value of something is 3, that something, so the x minus 5, is either equal to 3, or the something is equal to negative 3. So we're going to split the problem. When we get rid of the absolute value, we split it and make one equation with the positive answer and one with the negative answer. So my positive answer is 3, my negative answer is negative 3. From there, we go back to what we know about solving. We have no absolute value or parentheses anymore, so we add 5. And on this side, we get x equals 8. Over here, we add 5. And on this side, we get x equals 2. So that's why we get 2 answers, is because that absolute value is going to split our problem into 2 parts. So our answer for this one would be 8 and negative 2. You could go back and check. 8 minus 5 is 3. Absolute value of 3 is 3. 2 times 3 is 6. 6 minus 4 is 2, so that works. 2 minus 5 is negative 3. Absolute value of negative 3 is 3. 3 times 2 is 6. 6 minus 4, still 2, so we're good. Okay, let's look at another example. Feel free to pause if you need to. Go back and watch that again to help you understand. Whatever you need, this is for you to help learn. So please make use of it however you need to. So in this example, we're going to start with moving the screen and maybe refocusing just so that everybody can read everything. And green. Haha, there we go. Okay, so we're focused. Our example is the absolute value of 3x plus 2 equals 8. So again, we start by getting rid of this plus 2. So we subtract 2 on both sides, and we get the absolute value of 3x, because 2 minus 2 is 0. 8 minus 2 is 6. We're already up to that absolute value step now. So this is when we're going to do the splitting like we did up above. So when we split this, oops, sorry about that, I bumped the camera. When we split this, we split it into 3x equals positive 6 and 3x equals negative 6. Just one with the positive answer and one with the negative. So we're taking this number and we're just making it the opposite. Now all we do is divide by 3 all the way across, and we get x equals 2 and x equals negative 2. You can plug those back in again and check them. And you'll see that they both give you 8 in the end. I'm trying to decide. I think we should do one more example, and then we will be good for today. So one more example. You might have room for this at the bottom of your page, but I like to write rather large so you can read everything. Here we go. Example 3. 3 times the absolute value of 4x minus 5 minus 2 equals 19. So in this case, we have an absolute value with stuff inside. So remember that acts like parentheses, right? So we're going to get rid of this stuff on the outside first, and then we'll deal with the absolute value and the stuff on the inside. So getting rid of the stuff on the outside looks something like this. That's 3 times, so I'll divide. And I get the absolute value of 4x minus 5 equals 7. At this point, we split this because we got just the absolute value by itself. We're isolating the absolute value and then splitting it. So we get 4x minus 5 equals positive 7. And 4x minus 5 equals negative 7. Notice I just used the positive and the negative. And now I finished solving both of those equations. So I add 5 to get 4x. Ooh, I forgot to change colors. Sorry. I'm trying to make the colors be helpful. That's the wrong one too. 4x equals 7 plus 5 is 12. Divide both sides by 4. I'm not even trying to switch colors anymore. 12 divided by 4 is 3. Over here, add 5, add 5. 4x equals negative 7 plus 5 is negative 2. Divide both sides by 4. And x equals negative 2 over 4. But if you think about negative 2 over 4, really what we usually write is negative 1/2. 2 quarters is the same as 1/2. Okay, so our two answers to this one would be x equals 3 and x equals negative 1/2. So just keep in mind when you're doing these, the place to put the plus and minus in is when you get rid of the absolute value. If I had $1 for every time kids went from here to here and then said the answer was 3 and negative 3, I would be rich and I wouldn't need to teach anymore. So please don't make that mistake. When you see a problem like this, actually on the test I might even know if you watch the video, because you could like do it right and put a little smiley face next to it, and that'll be like your code to me. I'm not going to write it, but that'll be your code to me that's like, see, Miss Faust, I was paying attention and I knew to split it and make it the opposite when I got rid of the absolute value, not at the very end. So if you want to do that, make your teacher happy, go for it. If not, I hope you understood how to solve an absolute value function. Thank you very much and have a wonderful day.